Let's show you what's going to happen today. Today's going to be in two parts. I'm going to still be working on section 2.6. I'm going to be doing a lot of notes, so we won't go near any homework questions. We'll finish this part about 15 minutes, 20 minutes maybe, before the end of the day, because I want to talk, pardon me, I want to talk a lot about your test one. So there's a lot of things we need to get, information I need to get to you. So what we're going to look at right now is limits as x tends to infinity of a function. And these are very often called horizontal asymptotes. So here's a visual picture of what one of these would look like. Can you remember 141 when you were doing rational functions? Wasn't horizontal asymptotes one of the things that you had to deal with? There's a 3, there we go. So in this case here, as x tends to infinity, doesn't the function level off at 2? And as x tends this direction, which is negative infinity, doesn't it level off at negative 3? So the limit as x tends to infinity of this function, this one here, is 2. And the limit as x tends to negative infinity of this function is negative 3. Does that seem reasonable, that if you got a picture, you should be able to look at that and tell me what these two limits are? Okay. So what I'm going to show you now are some of the combinations, right? Some of the situations, visual ones, where you could get that type of thing happening. So in no particular order. This guy here would be the limit as x tends to positive infinity of the function. This one is leveling off at 2. Nothing that's special, but that can happen. This one is really just a special case of that. This one would be the limit as x tends to infinity of f of x, but this time the limit is 0. If the function, as you travel to the right, that's where infinity lives, over here, if it gets closer and closer to 0, right, basically the x-axis. Now, on your black pen now. What is happening in this question, right? So what's happening to the value of this function, its y coordinates, as x becomes infinite? Would you agree this function is just going to get bigger and bigger and bigger forever? So what do you think you write down for the limit when that situation happens?
Infinity.
Great. That makes sense? You can get infinity. And here is the fourth possibility. Can you imagine a sine curve, right? Up and down forever. What would be the limit of that function as x tends to infinity? What do you think we write down in that situation?
dne.
Correct. Does it make sense that in this situation, is there no there's no one number. Isn't this thing oscillating between 1 and -1, 1 and -1, and all the other values in between? And when there is not a specific place, even if that place is infinity, if that is the case, then that is a DNE, right? A does not exist limit. So limits can be numbers, 2 and -42, they can be 0, they can be infinity, plus or negative, and they can be does not exist. So visually, do you see what those guys could look like, right? There are not too many things that can happen as x tends to infinity, but these are the major ones. So far, so good. I'm not going to do the opposite, but couldn't I do pictures where you went this way, which is negative infinity? And they would look very similar. Oops. There we go then. Here's a picture for you. Here's a picture for you. It's got vertical asymptotes and horizontal asymptotes going around. And well, let's just do it verbally. What is the overall limit as x tends to -1 in this graph? The overall limit as x tends to -1.
Negative infinity.
Great. What's the overall limit as x tends to 7? That's the other vertical asymptote.
Doesn't exist.
Right, DNE. What's the right limit? Right limit as x tends to 7.
Infinity?
Yeah.
Positive.
Positive. And left limit, negative infinity. Great. So that was yesterday's work. We feel comfortable with that. What's the limit as x tends to infinity?
3.
Okay. Be careful with the last one, because there's only two. Right. In this type of situation, isn't there only two questions? X tends to infinity and x tends to negative infinity, right? That's the only two you're going to get. What is the limit as x tends to negative infinity in this picture?
Infinity.
Agreed. Can you see this graph is shooting upwards forever? So as you travel this way, isn't the answer just going to be infinitely large, plus infinity? That makes sense? Eli, does that make sense? Have you frozen, Eli? Because I can't see any visual movement. Okay. I'm assuming that, there we go. Right down. Issue there. If the curve pointed down the way, right? If it pointed that way, wouldn't the answer be negative infinity? And if it pointed this way, it's plus infinity. And if it kind of leveled off as it did here horizontally, it's called a horizontal asymptote, it would be a number. So there's a lot less answers to limits as x tends to infinity. Aren't the three answers? It's a number, like 2 or 0. It's plus or minus infinity, or it doesn't exist. So it's not like you have a lot of choices. And that's good. So that's how you do the answer visually, just by looking at a graph. Next thing we're going to do is a table of values. So how do you use a table of values to find the limit? It's this thing tends to infinity of 3x squared plus 17 over 2x squared minus x plus 1, right? Now, couldn't you just plug it into Desmos and do it through the picture, right? But we want to do this as a table of values, and how you can use the table of values and to figure out what this is equal to. So here's x, it's going to be my table, and here's f of x, which is basically this rational function. And I'm now going to, oh, Andrew just came in. I'm now going to do an online calculator because I was looking at some of my videos and I didn't realize, at least for mine, that when I do it this way, it's tiny on your screen. And so you might not always catch everything I'm doing. So hopefully this is going to work. Please tell me you're seeing a big TI-84.
Mm-hmm.
It's not been behaving today, this switching windows. My other class, I had some issues at the end. So here we go. I'm going to type in that function. So it's going to be a bracket. It's going to be 3x squared. Add 17. And then divide. Oops, I thought I hit the bracket. Divide. And then on the bottom, it's 2x squared. That looks a bit funny, but it is there. Take away an x, add a 1. And then you go to table setup and you make sure it's on ask. And then I'll go to second table. Now, when we did vertical asymptotes, suppose I was looking for x equals 2. Wouldn't I do things like 1.9, 1.99, 1.999, and things like that? That's the values I would use in my table. But I'm wanting to use a table to get the limit as x tends to infinity. So the values that I choose are a little bit different because of that. So I'm going to find what the function is at 10, and then at 100, and then at 1,000. Does that make sense? If you're interested in infinity, what it would look like. And I'm going to finish with 1,000,000. 1, 2, 3, 4, 5, 6. I think that's 1,000,000. Okay. Now, if you move to the right-hand side, although the screen says 1.5, can you see what the answer looks like to lots of decimal places? Right. If you were a betting person, what do you think the limit as x tends to infinity is probably going to be here? And it's not meant to be a trick question. What do you think it's going to be?
1.5.
1.5. Does that make sense? Does that seem obvious? I'm trying to think of a way to phrase this. That this technique would work, right? You just plug in the function, you pick numbers like 10, 100, 1,000, 1,000,000, and shouldn't you hopefully see a pattern, right? And in this case, as soon as I get back to my screen, let's see what the pattern would be. Right, so when you had 10, the answer was about 1.66 roughly. If you put in 100, it then became 1.51, if you round it off a little bit. If you do 1,000, it became 1.5008. And if you did 1,000,000, it was some, I don't know how many zeros, 1, 2, 3, 4, 5, 6, 7, whatever, right? Wouldn't that be a very strong indication that 1.5 was the answer? Now, I could do a table of values for x tends to negative infinity, couldn't I? Right. So if I did that, do you know the only difference would be that my choices would be those. Right, I put in -10, then -100, then -1,000, and I'd write down whatever the answers are. I happen to know that in this question, you get the same kind of values. So in this particular question, the limit as x tends to negative infinity is also 1.5. That's not always true. Do you know sometimes plus infinity, the answer's 4, but if you go to negative infinity, the answer's 2, right? They can be different, right? Horizontal asymptotes do not need to be the same number in both directions, right? And table of values would take you that way. Totally different question. But imagine I did a table of values like 10, 100, 1,000, and 1,000,000. And I got the answer 7, -3, 4, 2.2. What would be your most likely conclusion about the limit as x tends to infinity when the numbers just seem to bounce about randomly all over the place?
Doesn't exist because it's a sine function or cosine.
Or some function that just oscillates up and down like no particular rhyme or reason. So when the table has no discernible pattern, do you see the pattern here is you're homing in a number? If it doesn't have that, then you basically just say does not exist, right? That would be your reply. Are we good with table of values, or do I need to do another one? Do you feel comfortable about how you would put them into your calculator and play them? Yeah, I got enough nods, I'm happy. So the last technique that we're going to look at today, and that will be us finished as far as the work I want to do on these, and then we can start looking at the test, is try to look at my notes over here. How to find the limit as x tends to infinity using algebra. Okay, so before we tackle that question, I'm going to tackle a smaller version of that question. What would be the limit as x tends to infinity of 1 over x? Now, what I'm going to do, this technique is called brute force. All brute force does is that you plug in infinity as if it was a number. And then you have to kind of use some common sense. What number, because it is a number, do you think 1 over infinity is going to get you?
Positive infinitesimal 0.
Infinity.
Yeah, well, yeah, we'll just call it 0, right? Technically, it's an infinitesimal, but 0 is good enough. Would you agree that 1 over a huge number, and it's a huge positive number, is 0? You agree on that? That seem reasonable? 1 over a trillion is darn close to 0, so won't its limit be 0? So we take that as self-evident, right? Now, what would happen if it was 10? Well, you'd get 10 over infinity. Would you agree 10 over infinity is still going to get you 0? Well, what about 10 over x cubed? Well, what's infinity when you cube it? Well, isn't it still infinite? And so won't that still be 0? Do you see then that if you have a number on the top and any kind of power of x on the bottom, won't the limit of that fraction be 0? Can we assume that that is self-evident, right? That 10 over any power of x you like, right? 10 over x squared, 10 over x, 10 over x cubed. Oh, just thought of one. If x is infinity, what's the square root of infinity? Isn't it still infinite? So won't the answer still be 0? So 10 over anything with an x. So it doesn't even need to be a power now. Can't it be a square root of x and a cube root of x as well? Number on the top, something to do with x on the bottom. Answer is 0. Okay. Keep that thought because we're going to use it now. Suppose I wanted to find the limit as x tends to infinity of this guy, right? The one we did through tables. So on the top, it's 3x squared plus x take away 1. And on the bottom, it's 2x squared take away 2x. You might think, well, how are we going to do this algebraically? Well, I'm going to divide everybody in the top by x squared and everybody in the bottom by x squared. Now, we've used this strategy. It might not look like it, but we've used this strategy before. Do you know if you multiply a fraction by a special version of 1, don't you still get the same fraction? It just looks different. Now, that might not look like I'm multiplying by a special version of 1, but I am. Because the special version of 1 I am using is 1 over x squared over 1 over x squared. Isn't 1 over x squared the same thing as divided by x squared? Now, why is that helpful? Well, let's see what we get. Each term gets divided by x squared. So that guy gets you 3. This middle term, when you divide it by x squared, gets you that. And this guy at the end, you get that. This fella gets you 2. And this fella gets you 2 over x. So our original fraction has now turned into this very weird looking fraction. So far, so good. Now I'm going to do the brute force part. I am going to replace x by infinity and then see what we get. So it's going to be 3 plus 1 over infinity. Take away 1 over infinity squared, which is still infinity. 2, take away 2 over infinity. Now, don't start thinking of these as fractions or anything. These are really just placeholders for what I'm about to do. Isn't 1 over infinity 0, and isn't negative 1 over infinity 0, and isn't negative 2 over infinity 0? Can you see that the answer just ends up being 3/2? Which is 1.5, which is exactly what the table told us, isn't it? Does that make sense? That process of dividing the top and bottom, in this case by x squared, allows us to get the limit as x tends to infinity. Now, could I do the limit as x tends to infinity with this? Not a problem. Same. Okay, would you agree that 4 over minus infinity is still 0? Right, so you still get zeros, just technically a 0 minus infinitesimal, but we are not interested in infinitesimals now. We just want to say it's as close to 0 as anybody cares about. Any questions about that? I think that went pretty smooth then. Do you want to see another one, or shall we finish this and start looking at the other stuff, which is getting ready for the test? Do you want anybody want to see another one? You'd like to see one more, right? Let's do one. Let's do the limit as x tends to negative infinity, right? Just to show you it makes no real difference. I'm going to have 3x cubed take away 2x squared plus 1. And I'm going to have 6x cubed plus an x plus a 7, right? So we are going to be looking for what the limit as x tends to negative infinity of this guy is. Okay. So you look at the guy here and you look at the guy here. Would you agree that x cubed is the guy that I should be using? Right? Whatever the biggest power is, that's the guy I should be using. So I'm going to divide top and bottom by x cubed. So what we now have that guy gets you 3. Divide him by x cubed and you get that. Divide him by x cubed and you get that. Divide him by x cubed, you get that. Divide him by x cubed, you get that. And divide him by x cubed, you get that. Are we comfortable with that step? Right, now we do the brute force. Now the only difference here is negative infinity. Don't let the negative infinities bug you too much, but I'm going to take care of them. 3 take away 2 over negative infinity plus 1 over negative infinity. Oh, if you take negative infinity and you cube it, don't you still get negative infinity? Right, are you happy about those two guys? Okay. The bottom's going to look a little bit weird in one place. Why is that middle one 1 over infinity and not 1 over negative infinity?
It was x squared.
Yeah, and so negative infinity squared gets you plus infinity. Doesn't it not really matter if you forget that? Because what's going to happen to each one of these guys is exactly what happened the last time. Isn't 2 over negative infinity still 0? 2 over minus 22 billion trillion, isn't that just 0? So what do we get? 3 take away 0, add a 0. 6, add a 0, add a 0. Doesn't really matter about the zeros. The answer is a half. Do you like this technique?
Is the answer always going to be the first two numbers?
Very interesting question. No, but these two examples I did, it was yes. So if you're wondering what he was saying, if I paraphrase it, do you notice that the first two numbers are 3 and 6, and the answer is eventually 3, 6 and a half? That will be true when these are the same power, which they are. But after the test on Tuesday, we're going to return and we're going to do combinations where the top power might be x cubed, but the bottom power might be x squared, right? And when the powers are different, then all bets are off, right? The answer to the limit won't be 3, 6, right? But if they are the same powers, right? If the leading coefficients are the same powers, yes, what you said is correct. Okay, I'm going to call that quits now unless we get any more questions so that we can start looking at the test. Okay. While I'm doing this, do you want to say hi? Because I might forget to ask you to say hi. I need to set up some stuff here, so while I'm doing that, you might as well get ready for whatever's. Do that. Are we on the right class? I believe we are. Yes, I think we're about ready. Just make things a bit bigger. That looks good. Okay, let's get started and talk about our test, which we all should know is going to happen on Monday. Agreed? You all knew that? Test 1 is Monday. Right. Are you looking at our Canvas page? Now, I had the same trouble with the other class. I don't know if it's student view that's causing the trouble, but I have to do this, which is weird. It should be working now. Can you see it? Okay, I got nods there. I was panicking for a minute. Right, so this is what your Canvas page looks like. Do you notice that there's a new module right at the top called Test 1 Information? Right. So on the day of the test, on Monday, you're going to go here into Canvas because this is where your test is going to be living. And this is where you're going to do a whole load of other things as well. So sometime in the next few days, you're going to watch this video if you haven't already. And it tells you how to use Adobe Scan. You're going to click this and it is how to get Adobe Scan. So Adobe Scan is a piece of software that you can put onto your Mac phone or your Android phone. and it basically, you use the camera on your phone to take pictures of your of your test, because your test is going to be done in paper. It's not going to be done in WebAssign. It's going to be physically done in paper. Think of the analogy. Can you imagine coming to class and I wrote the test up on the whiteboard, and you would do the working on paper and you'd give me the paper, right? It's that equivalent, right? So you're going to do your test, and once you've finished your test, you're going to take pictures of it using Adobe Scan. Adobe Scan allows you to take that and turn it into a PDF, right? And that's the thing you're going to send me. And you're going to send it to me essentially by uploading it. And you can watch this video here and it will show you how to upload your working into Canvas. And then this guy here is where you're going to do it. So you're going to click on this guy here and you're going to start the assignment and you're going to choose the file and you're going to pick up the file, picking that one up. You're going to say, okay, and then you're going to submit your assignment. Right, that's how easy it is, right? You're going to go in there. Now, if you want to practice just uploading stuff, you know, take a page of, hi, this is me name. Use Adobe Scan to take a picture, right? Just go through a dummy run so you feel comfortable with it. And then just upload it here. It won't be a problem, because when you do the real version, it rubs out the old one and all I will see is the test, right? So it's not a biggie. So if you want to practice it, that's what you would do. Now you have got, that's not been changed, I apologize. That should say 10:30. You have got until 10:30 to get this done. That's your time limit. Now, where is your test going to be? Well, it will be here. When you click on that, this will open up and you'll see your test. It'll be in PDF form and you'll be able to use it. So you'll just read the question and you'll write your answers down in paper and you'll call it good. You have until 10 o'clock. Well, let's tell you how it's going to work. You're going to turn up into Zoom, just like we are right now. You're going to have the video on, and I need to see video or you can't take the test. And the reason for that is for security. I want to make sure that Sabrina doesn't have her big sister, if she's got a big sister, or anyone else at her back telling her how to do it, right? So it's just my way of keeping things honest for everyone, right? So I need to see you. And plus, if you've got a question, can't you just say in Zoom, hey, I can't read that. Is that a 3+ or a 3-? Because it looks, I can't tell. Or whatever the question is, I can't think. Do you want the overall limit here or something, right? Then I can tell you. So that's kind of what that is about. Now, let me hopefully get back here. All of that look good? You happy with that? Right. Let's close these things off. The only thing that will be visible to you in Canvas will be this stuff here, plus one more guy. Desmos will be here. I haven't put him there, but he will be there. Because you can use Desmos, right? You're allowed to use it. So what's your test going to be about? And what can I use and what can't I use? Let's talk about that. Oh, let's pause a minute, though. Are there any questions about so far? Right. When you are in Zoom, you will stay on Zoom until you have uploaded your work and it's in Canvas. Now, although officially you've got an hour, the test shouldn't take an hour for most people, right? A lot of people are going to be finished the test in 40 minutes. And then 5 minutes later, it's in Canvas. And if it is, it's bye-bye. You've done everything, you can leave, right? The half hour kind of is really just a grace period because maybe you're having trouble getting the bloody software working. That's why you should practice it so you get all the kinks out before you even need to really do it. It's not a good idea to wait to the day and then find out, oh, I don't know how to finish this. I don't know how to download this or something. So where am I ranting on about? So you have until a drop dead date time of 10:30, right? Okay, that's me finished with that. Any questions now before I move on to tell you what's in the test and what you can and can't use in your test? Okay, so Canvas will
I have a
disappear
question.
except for that. Yes,
Do we only write down the answers or do we have to show work?
you must show working.
Okay.
And that in fact, I'm glad you said that, although I was pretty sure I was going to tell you that anyway. That is a biggie.
Did you say we can? I don't know if I missed that.
So now going to go back out and back in again, and hopefully you are now looking at, oh, I may have to go back in and out again. Are you looking at Cengage right now? Okay, good. So let's tell you about what's in your test. Well, there's going to be 4 questions. And the topics that you're going to be tested on are 2.1, 2.2, 2.3, and 2.5. 1 question from each of those. You're not going to get a question intro to WebAssign, and you're not going to get a question like I promised on the formal definition of a limit, right? So forget those. You are allowed to use Desmos. A copy will be in Canvas, so you can use it. No biggie there, right? And you are allowed to use any physical notes that you have written down. But WebAssign will disappear on the day of the test. So if you go into WebAssign, nothing will be visible. None of the homework will be there. It's not gone forever. I've not rubbed it out. I'm just hiding it, right? So you can't use WebAssign because there ain't any WebAssign to use, right? But you can use anything that you've physically written down. Now, if you've written good notes, it's going to be a help. But if you have to look up notes to do every single question, you'll just run out of time. And that's a problem. So make sure that you are well prepared for the test, and the notes are more like a psychological crutch for you. In case you stress out, you can say, oh yeah, I was right, and off you go and do it. Now, someone mentioned working, so let me be clear about that. I have got to see appropriate working for every question. Because in a lot of these questions, couldn't you just go to Desmos and find out the answer was 3/2 and just write 3/2 down? But I didn't want that. I wanted to see algebra. I wanted to see a table of values or whatever. I will be quite clear about what I want. So I might say, you know, use table of values to do this, or whatever I may ask. Show me working, because that's where you get the points. You will also get partial credit. So if you do the method correct, but 3 times 2 turns into a 5, or you lose a sign, you know, or something, it's not the end of the world. You'll get most of the points, as long as it's trivial. If you only get halfway through before you get stuck, then you'll get half the points. You got halfway through, right? So partial credit is going to be available. There are going to be some questions where working is not expected. And that's fine. Hopefully they're obvious. Can you imagine a question where I just gave you a picture and I went and said to you, where is it discontinuous? Or what's the limit, you know, the right limit, you know, x to 3 plus or x to 3 minus. If I give you a picture, don't you just look and say, does not exist, or 4. I only expect working for those, and that is fine. If you're not sure, just say to me, do I need to show working in question 3? And I'll say, nope, answers are good. Or, yeah, you should be able to show me some working there, right? Right, question time. Anything you want to know?
Can you use the TI-84 calculator?
Yeah. Nice short answer, yes. Next question.
Around how many questions is the test?
4, 1 from each of the sections, right? Some questions might be ABCs. You can imagine if it was a graph question, I might ask you 3 or 4 things about the graph, so they'd be called ABCD, right? But there would be 4 questions. The questions themselves, I'm not here to catch you or, you know, do trick questions. The questions I use will be very, very similar to what you did in WebAssign homework. Right? It won't be the same questions. That won't be fair because some of you would have done that question and others won't, but they'll be similar. So you should be able to look at those questions and you should say, yeah, I've done things like that. You won't be able to, because I'll make sure, what on earth is that about? We never done a question that looked like that before, right? That ain't going to happen, right? Just, that's not fair. Although I may ask you kind of thinking questions, so it's not too obvious what you have to do. More questions? Do I have any more?
Yeah, have to use Adobe Scan, or can we use our computer?
You can. So Eli's right. So if you've got a printer that can scan your stuff, for instance, do that. Some of you in other classes, like maybe English, already have a piece of software because English wanted you to do the same kind of thing. Cam Scanner comes to mind as one, but there's others. Yeah, use that. All I care is that it turns into a PDF and it gets to me. I put Adobe Scan out there because I find it quite easy to use. And if you don't have anything, at least now you've got something, right? So you can use that. Strong advice is do download Adobe Scan as soon as you can and play about with it and try and upload it into Canvas, you know, just to be sure that you know how to do it. Once you figure out how to do it, it really only takes about 5 minutes, right? You don't need half an hour to do it. But you know, that's kind of there if you need it. And you're going to still be on Zoom. So hopefully you don't have an 11 o'clock class. But if you do have a class that might interfere with that, tell me and I can make arrangements for you to do a different version of the test at a different time. Essentially, you will do it 1 hour earlier because I have another class that's going to do it then. Right. So you can actually, you know, oh, I've got a chemistry class, I might interfere with my chemistry class. You can just do it at 8. And that way you can do it at 8 and you'll be finished long before your normal class is over anyway. I think I've thought of everything, but you know, that doesn't guarantee I have. Are we good? Is everything you want to know about the test can answer to you?
How many points is the test worth?
They're all worth 100 points, but that's just to make them easy to calculate. Your tests are 20% of your grade. So since there's 4 tests, there's 5, but I count the best 4. Each test is 5% of your overall grade. Right. So if you did a perfect on it, that would be 5%. Right. But it's out of 100% because that just makes it easier to calculate and percentages and all that other stuff. Once the test is over, you will be given, as soon as I have time, a report. And the report will be your participation grade, your homework, which by the way, you've got until midnight Sunday to get done. And that's all the way up to and including continuity, which you can see in WebAssign. That and your test, and you will get what your grade is so far. I'll give you a kind of ballpark figure. And then I'll send later a solution to the test so that you can actually see what each answer looks like, and then you can look at your own answers. Hopefully you kept your test, right? And figure out what you did wrong.
Could you say again what the time frame for it is? Is it just our regular class times?
Regular class time, but once that time's finished, you have a little window. Half an hour is probably too long, but you've got a little bit of time to take photographs, right? Use Adobe and get it uploaded to Canvas. But you've got an hour, essentially, to do your test.
Okay.
Most people won't need an hour. I would guesstimate about 45 minutes would be a typical time. So you could probably do everything, including the Canvas thing, inside the usual hour. Right? Most people. Okay. You have to stay on Zoom until it's finished. So even when the test is finished, I still want you to be in Zoom until you finish doing the Adobe scan or whatever way you got it. And then once you've got it into Canvas, you will do one last thing for me. You'll say, did it upload? And I will be able to tell you it's here, bye-bye, right? Because the last thing you want to do is think you've done it right, and then I'll say, no, never arrived, do it again, right? That would be bad news for everyone. Keep waiting. If there's no more questions, once we get to that point, we'll say bye-bye. Any more? Okay, your weekend is dead. You belong to me this weekend. You are going to be so prepared for this test that when you look at the questions, you're going to laugh at how easy they are, right?